So in today's video, we will look at a concept called traffic engineering and what that means. And we will try and demonstrate the traffic engineering concept using a tool called PBR, which is standing for policy-based routing. So we're going to configure policy-based routing in VOS1. Before we begin, let me just demonstrate or illustrate what we're trying to achieve. So we got VOS4 and all of the other routers are configured in an OSPF area 0. So all the links are connected through OSPF. There's a video before that talks about OSPF routing. So in this case, we're just doing area 0. And the loopback is configured with two addresses, 4444 and 44444. These two are advertised and they're getting learned through this path, and therefore this is a smaller cost or less cost path. Therefore, this path is preferred when VOS1 takes or wants to go and reach either 44 or 4. This cost or this path is higher cost, and therefore it's not installed in the routing table. Only when this link fails will this path or this route will get installed from here. But for now, we will see that the routing table has the route for these two, 4444 and 44444 in VOS1's routing table, and both the routes are going through this path. So the first hop is 10122. What we're going to do is write a policy using PBR, policy-based routing, and we're going to tell VOS1 to take 10133 when you're trying to reach destination 4444. Just for 4444, not for 4444. So let's write that policy in VOS4, but first let's see what the trace routes and routing looks like. So here in VOS1 we have 4444 going to 10112, 10122, which is this guy here. So let's do a show IP route match to simplify. Show IP route. And now we can see that 4444 is going through 10112, which is this guy. And 44444 is also going through 10122, which is this guy. So for both the destinations, the path is this one. Okay, let's change that for just this 4444, not 44. Let's write the policy for that. And to do that, we're going to go into the config mode. And since this demonstration, the traffic is getting originated from the local router, you're going to write the statements for local route traffic. If your traffic is coming from any other interface, you don't have to write the first two statements, which says local route. So in this demo case, we're going to write set policy local route rule 1 set. So we use the tables in traffic engineering, policy-based routing, set table 1. So basically what we're saying is for anything that's generating from this local router, any traffic for this policy, the table is table 1. And then we're going to say it needs the source address. So we're going to say the source could be anything. We're not concerned about the source here. And now that's about it for the local policy, the traffic from a local router. Now let's go and look at the actual policy. We're going to call it set policy route, and then we're going to say PBR, policy based routing. You can name it whatever you want. Rule 1, and the destination address is going to be, we're writing for 4444. And then we're saying that if this is the destination, then set the table to be table 1. That's the routing table number, not the default routing table. It's a table 1 is the separate routing table compared to the default routing table that we looked at. So table 1 is all set. Now we just need to do one more thing. This is just the policy. That's about it. 2 statements for the policy. Now we need to go write a static route for the table 1 to set the next hop to be 10133. So we're going to say set protocol static table 1 route for this guy /32. Put a next hop to be 10133. Now, before I do a commit, let me show you the trace route for, you can see right now it's taking this guy for 4444, and it's also taking the same path for 44. So the next hop for 4444 and 4444 is 10122, which is this guy right here. Now, after we do the commit, we do run trace route 4444. The next hop is 10122. But if we were to change the trace route to 44, and the next hop has gone this guy. So now you can see that we have effectively changed the path for 4444. It's going through 10133 instead of 10122. It's still taking 4444 destination through this route. That's the default routing table that we saw. But for the policy that we wrote is forcing the next hop for 4444 to be this path. Next hop this. And so if you were to look at the routing table, show IP route, it still looks the same. For 444, it's saying 10122. And same is for the, simplify it. See, the next hop still sees the same. It does, the default routing table does not give you the next hop for 10133 here. It's still showing 10122, but when you trace out to 4444, your next hop is really 10133. So it's actually taking this route, and that's your policy routing.